libraries. Makes for a very paranoid person once you start to think like this. Right? You start wandering around and you can't trust anybody. So what do we try to do? We try to reduce that attack surface. More attack surface. Attack surface is more or less just our entry points. More attack surface means more chance that an attacker will have access to our system. Right? More attack surface means more security issues, which means more headaches for us. Right? So this popped into my head when I was sitting in the audience for the last talk. It was like, more attack surface, more problems, right? Like, the more attack surface we have, the more security work we have, the bigger our security problems are. So, clearly, we look at this and we say, well, that's an easy thing to fix. We'll reduce our attack surface. Now, attackers also look at this, look at our software in the same way, right? It's the same kind of idea. We have attack surface. We look at it and say, well, if I were going to attack this system, these are the entry points that I would use. And the interesting thing about attackers is that they know the system really well, right? They look at the thing and they say, well, you're using these protocols, you're using this entry points, you're using jQuery, you're using JSON blobs or binary objects notation blobs, you know, all this kind of stuff. And they say, well, how can I use that to my advantage? How can I bypass your input validation? How can I manipulate your server-side information stores, right? And so they identify your entry points, they exploit the entry point or the back-end service behind it, and then they try to gain access. So in our software, we're going to do the opposite, right? We're going to understand our attack surface before they can, right? And then we're going to reduce that attack surface so we don't expose anything out there. Oh, so I notice a few people are feverishly taking notes. If you want these slides, I'll put some cards up here and just email me and I'll send them off. So don't panic on the note taking. I mean, take notes if you want. So we're going to reduce that attack surface as much as possible. And then on our small reduced attack surface, we're going to test those interfaces really, really well. Right? Does that make sense? And so, you know, if I were going to go into Battlefield, right, one of the ways that I could reduce my attack surface is by adding armor. Right? I wouldn't wander out into a battlefield completely like wearing street clothes. Right? I would put on some metal plating and stuff like that. So we're going to do the same thing for our application. And we're going to do it early, and we're going to do it often. So once we do all of that, we're going to do some architecture and design documents. We're going to validate those kinds of things. We're going to validate our code. And throughout the whole process, we're going to be making these little security changes. So, did I miss a slide? No. So how do we actually accomplish this task? How do we actually reduce our attack surface? How do we enumerate the attack surface? So first of all, we might want to list out all of your entry points. UI, libraries, network I/O, pipes, file I/O, databases, all that kind of stuff, right? And all the features. And then we're going to rank them. We're going to say, well, is this entry point, do you have to be authenticated to access this entry point? Right? Or can I get to this anonymously? Right? Once I've authenticated, do I have to be a regular user or do I have to be an administrator? Right? If I have to be administrator, like there's only going to be 2 admins on the system, and you know that's Jim over there, and I can see him, and I've known him for 5 years, and that's Sally over there, and you know she seems pretty reasonable too. So if I have to be an admin, that means that I have to leverage other vulnerabilities or start to mistrust our admins. So then the next one might be like, do I have to be local? Right? Do I have to be at the machine? Do I have to be on the LAN? Or can I do this from anywhere on the internet? Right? This will help us rank these as well. And then finally, I put in UDP versus TCP. And TCP requires, full IP handshakes and stuff like that. UDP, I can just send from across the internet, kind of toss this packet and cause issues. So if I don't have to tell you if you don't verify my IP, then I can do stuff like IP spoofing and things like that. That even makes it easier to do these things. So mapping this attack surface and reducing it is one of the more important things that you'll ever do. Think about file formats, think about all your sub-protocols, think about all your HTTP verbs, all your other SMTP verbs, all those kind of weird actions that your system can do. Right, so we all know about get and post, right? Everybody knows about those. What about head and delete and trace? What if you're using WebDAV? Right? What if you're using some sort of SMT protocol? It's an SMTP protocol. Right, so we need to think about the complete attack surface here. Now, it's not just about turning things off, right? It might be about running with less privileges, right? So we might move from being anonymous to authenticated. That's a good way of reducing attack surface. Maybe saying, well, not every user needs to be able to write to this database table, right? Well, we're going to say you have to be not only just a regular user, but you have to be an advanced user or something. Again, we've reduced that attack surface. Maybe moving something from UDP to TCP. So now we know that you're not IP spoofing. Maybe we have an update service that's constantly on. Maybe we'll turn that off and have just small windows where it pulls out for the system. And then we kind of add to the security of the system a little bit of like a timing-based type of thing. So we have things like we're running a system, maybe running not as system. And how many folks? I see a few familiar faces out there, and I did a 2-day class on Tuesday and Wednesday, and for this class I wrote this vulnerable website, and we ran it as the normal IIS user. And in the vulnerable website, there was a directory traversal attack where I could arbitrarily read files from all over my file system. And what was kind of nerve-wracking was that we were able to read things off my C drive. We were able to read things in the Windows directory. We were able to read things off in my My Documents folder. Like reducing that attack surface simply by running with a lower privileged user would have been an easy way to secure that system. Changing things from like, reducing the number of lines of code is another way we can do this. So first of all, reduce the amount of running code. A feature that's not turned on isn't vulnerable, right? If you don't install that module, it won't be vulnerable. I remember, what was that, IE 5 or 4? They decided that they were going to add the Gopher protocol to Internet Explorer. Anybody remember Gopher? When was the last time you used Gopher? I get 1980. Yeah. So they added this feature in 2001. The clincher, of course, was that after they added that feature, they what? They increased their attack surface, and there was a buffer overflow. So everybody downloaded this update for a feature they didn't want, and then they were vulnerable to a buffer overflow, which would allow an attacker to take complete control of the system, install malware, the whole 9 yards. That's just not fair. Like, I don't want that feature. And now you mean that I'm going to be vulnerable to viruses and all that kind of stuff? That's too bad. So let's talk about threat modeling a little bit. So threats are not the same as vulnerabilities, okay? I made an analogy a couple of days ago that I happened to be holding a hot coffee in my hand. I said the threat here is that I'm going to take this hot coffee and I'm going to throw it on you, right? And I would then be the attacker, right? And you're vulnerable to that attack because you're not wearing any hot coffee protective suit. Right? So does that make sense? Like, you're sitting there vulnerable, but there's no attack yet. And there's no, you have the vulnerability of not wearing the suit. You had the suit, and you've mitigated that threat. So even if I attack you with my coffee, the issue isn't there. All right? So threats are always there. I can go around saying I'm going to throw coffee on everybody, and it would be up to you guys to wear your protective suits. And if you don't, I throw coffee on you, and you're attacked, and I exploit that vulnerability. That makes me kind of a crazy person, right? I'm like, well, I want everybody to wear their protective suits, so I'm going to tell everybody that I'm going to throw coffee on them. Actually, that sounds a lot like some security researchers I know. So threats live forever, right? They're because people think of bad things that they could do to other people or systems. So we're going to add our mitigation and solve that threat. So when we start to threat model, we're going to first identify all the threats and vulnerabilities that are kind of inherent in our application. So web applications have kind of a set of threats that we need to address, right? And this is the anonymous internet user, maybe a distributed denial of service attack, right? Every single web application out there is vulnerable to this. And we can add protections in place to make sure that that doesn't happen. But in the end, right, anybody that's ever been on the internet for a while and seen a server that was under too much load has seen a distributed denial of service attack. So we want to first identify all those threats and vulnerabilities. Then we're going to think about determining countermeasures. How can we mitigate those vulnerabilities? So maybe a threat is that a user or an attacker steals some user's credentials, right? And how can we mitigate that vulnerability? Well, maybe adding SSL or fixing SQL injection vulnerabilities and things like that. So the next step is to do an architecture and design review process so we can understand security objectives, understand our application architecture, those kinds of things, and then we can kind of react to the system in that way. Once we've created our threat model, we're going to update and improve. I think that too many teams tend to create their threat model and then tick the box and put it on the shelf. Right? The threat model is this kind of living document. As we add features, as we go through the phase, as we learn more about our software, as we do different things, we're going to update that threat model all the time. Because we're going to use it later in the phases, right? We're going to use it to create a test plan. We're going to use it for developers to make sure that they're mitigating the right threats, and those kinds of things. Also, we're going to be thinking about specific legislation, other requirements like Sarbanes-Oxley, GLBA, HIPAA, PCI is the big one now, and Senate Bill 1386, which is now a law. Anybody familiar with SB 1386? It's one of my favorites. So it's a California Senate bill, now law, and essentially it just means that if you have a data breach, you have to let everybody know. Let everybody that's a California resident know. If the data is not encrypted, right? If you haven't made you're telling me about that. So if you haven't made, if you have reason to believe that the attacker could have the access to the data, then you have to let all of your California residents know of the data breach. And the funny thing is you don't have to know if they're California residents. So if somebody types in a mailing address and that's all you have, and it's for New York State or Nevada or Washington, you still have to notify them or you'll be out of compliance if they're a California resident. So that's kind of an interesting one. So in order to do this whole threat modeling task, we generally do this kind of activity cycle. And the first cycle, the first phase is kind of to identify our security objectives. And this is kind of general security